Okay, good soul, everybody. This is our group, the Launchpad group. Its girls are Pawana, Hanka, Arshleen, and me, Ismel Batista. So now we are going to talk about the internal design of our facility. Since everything starts with drawings and sketch, this is how our facility started. In the first, these are some modern designs that we also designed. Another one of the beds and in general. So, applied technologies. Now we are going to talk about the technologies that are in our facility. Machines and technologies necessary for the facility operation. The first one is the ISRU plant, which is the one that makes the fuel for the facility. It's the one that produces methane and oxygen using Martian CO2 and ice. The second one is the cryogenic tanks, which are the ones that store the propellants at very low temperature until the launch. Basically, propellants are gases that are contained in very cold temperatures. So whenever the rocket wants to start to fly, they are disposed and it flies. Okay. So the next one is the water ice processing, which is the one that purifies and gets clean the water in general, also for astronauts to drink it, to make the fuel. The next one is the power generation, which in our facility we use solar panels. They give them electricity and in general any form of energy for the base. The next one is the thermal system, which keeps the equipment and the fuel in the right temperature since they need to be really cold, and also the facility needs to be in a 20, 30 temperature for general life. And the next one is the control and communication center, which is the ones that provide some communication from Earth and is the way to in general know if something is going wrong in the other facilities or in mine. And then we got the safety alarm system, which is the most important one, which shows if something is going wrong, it flashes up so we know we can stop accidents in general. And the most important one, I think, is the workshops and 3D printer, which makes parts for the facility. Can you go next? Okay, so the next one is the possible resources to generate in STU, sorry, are transported from Earth. The resources that are marked in or SITU are methane from the cryogenic tank. It's made from CO2 and ice, Martian ice. The next one is oxygen because it's important for our living, and it's made also from CO2 and ice. The next one is the water, which is made for the water ice processing. It's extracted and purified from Martian ice also. And the resources transported from Earth are some spare and tools for mechanical storage and in general use for the facility. Some initial fuel because we need to have some fuel from the earth and equipments for power generation for the until the systems are fully made in the facility. So the next topic is management. Our organizational structure is basically, first of all, I want to clarify that no one is higher or lower than anybody, so we are all on the same level. So there is an operation and safety officer, which is in this case Pawana. She watches control center and rocket, and she also checks for fire and gas, and she also organizes tools and repair the parts. Our next one is the life support and researching, in this case Hannah. She is the one that manages the oxygen and water system. She grows food in the vertical garden. And um, the next one is Arshleen, with the propellants and fuel specialist. She makes methane with an oxygen. She's the one that controls the RSU plant. She checks the fuel tanks, the cryogenics one, and the next one is me with the power thermal engineering. I run power systems with the solar and the batteries that we have there, and also I control the heating and cooling. Also, it's very important that everybody must take care of the dorm, kitchen, and bathroom. We also need to water the vertical garden and keep the common areas for rest and teamwork. And the astronaut profile and responsibilities that is going to be needed for our facility is that they have some science and engineering skills, also be strong and healthy, also be a good teaming worker, and be trained for the use of the machines and repairs. And the responsibilities we need somebody to check the base systems, check fuels, water, and power, keeps the crew safe, grow food and manage oxygen, do experiments and collect data, communicate with Earth, and water the vertical garden. Very important. So the next person is going to be Pawana, I believe, and she's going to be with you.
Good, sir, everybody. I'm Bhavna and I'll be presenting from point 6 to point 10. So I will begin with point 6, that is astronaut training program. At a launchpad or a spaceport, all team members, including astronauts, engineers, technicians, and system operators, complete intensive training before duty begins. This program covers technical systems, operation, fueling procedures, emergency shutdown, evacuation, firefighting, and hazardous material response. Regular drills and simulations ensure everyone is prepared for critical launch and shutdown scenarios. Teamwork and clear communication are emphasized, with staff trained to lead and follow effectively under pressure. Only those who pass all required technical, physical, and mental certifications may participate in launch operations, and trained safety officers must hold additional professional qualifications. Safety and readiness are treated as the highest priorities. And now I will move towards the point 7. Anna, can you go to point 7? Yeah. So the point 7 is YouTube videos to train astronomers. Here I have uploaded a lot of variety of YouTube videos to demonstrate astronaut and launch crew training, providing real life footage from NASA and other space agencies. Such videos are recommended for anyone interested in astronaut preparation, space operations, or understanding industry standards and challenges. Now I'll move forward to slide point 8. The point 8 is resources necessary for 1 week. To maintain full operations for 1 week, the launchpad relies on rotating personnel shifts, ensuring continuous readiness particularly for range safety officers, protective gear, emergency kits, firefighting equipment, spare technical parts, food, water, and other basic supplies are required. Additional support tools such as weather monitoring systems and airspace management contribute to safety. Efficient routines, routine inspections, and strong logistical planning keep systems functioning and the staff supported through operations. And I'll move forward to point 9, guidelines to be provided to other facilities, stations. Strict access control is enforced around launch operations. Only authorized, fully trained personnel are allowed on site during hazardous activities. Reliable station wide communication keeps all departments like health, power, engineering, and more informed about launchpad status at all times. Coordination in emergency drills and the thorough documentation of incidents and lessons learned foster continuous improvement and overall safety of the station. Now, point 10. Now we'll begin with protocols. Specific protocols or routines of the facility. The Launchpad's daily routine begins with a team briefing covering operational plans and safety updates. Engineers and technicians conduct systematic inspections of all pad and rocket systems. Communication and safety systems are tested for proper performance. During countdown and launch, only essential staff remain at the pad. After launch, the facility is thoroughly inspected, results are recorded, and preparations are made for the next mission. Thank you. I'll forward it to Hannah.
Okay, this is my part, and I start with protocols of safety. I think safety is the first rule of any spaceport, and we divide the launch area into zones: hot zones for the rockets and payloads, where only trained crew can enter, and safe zones for visitors and support staff. Thing keeps people away from unnecessary risks. Monitoring is our second layer. Sensors check pressure, CO2, radiation, and temperature, giving early warnings if something is wrong. In emergencies, we use fast response protocols, quick evacuation, automatic hatch closer, and remote shutdown of systems. And the principle is always protect the people first. Crew safety also depends on personal measures. Suits protect against toxic fumes, and the body systems ensure nobody works alone. And finally, training makes everything effective. Drills for fires, leaks, or rocket failure prepare the team for to react calmly and without hesitation. And together, these steps build a strong culture of safety. 12 is protocols of occupancy and entertainment. Living and working on Mars base is not only about survival, but also about well-being. And to keep the crew motivated, we combine work with structured recreation. We are a system let people explore Earth or Mars landscapes, and simulators offer games and training at the same time. Social life is equally important. We plan cultural events such as music or movie nights, cooking together, all small competition, and these activities build team spirit and reduce stress. For the mental health are also necessarily quiet moments like meditation, journaling, or simple reading give personal space in a very crowded environment. And with biofeedback devices, crew member can even monitor their stress levels. And finally, flexible scheduling aligns work, rest, and sleep. By balancing duty with relaxation, we make sure that performance stay high and the crew feels good. 13 is protocols for food microproduction. In this case, food is more than nutrition. It supports health, morale, and even air quality. And our main system is hydroponics, plant grow in the water, controlled nutrition and pH. And this method is efficient, clean, and reliable. And we use light for photosynthesis, support healthy and fast plant growth. Plants also affect the atmosphere, so sensors track oxygen, CO2, and other compounds. In this way, food production directly links to air quality. To make this system safe, we add redundancy, backup pumps, automated irrigation, and remote control options. Even if something fails, then plants continue to grow. And the crew takes an active role through inspection, tasting, and monitoring. Protein protocols for 3D printing. 3D printing is a powerful tool for a Mars spaceport. Its main role is to produce objects that cannot be quickly delivered from Earth, like spare parts, tools, or modular components for the habitat. We use several types of printers, metal power printers for strong structural parts, plastic filament printers for everyday tools, and optional ceramic or biopolymer printers for experiments or decoration. Operation in remote and secure. Crew can start and monitor printers through cameras and sensors without standing next to the machine. And the benefit is immediately access to critical components, reduce dependence on supply missions, and greater flexibility. Other parts is spin-offs. 15 is technologies and outputs applicable to Earth. Many technologies designed for Mars also solve problems on Earth. For example, closed-loop water recycling can support regions with water shortage or disaster zones. Control environment agriculture like hydroponics or algae systems can be used for urban farming or sustainable food production. 3D printing with recycled materials help create a circular economy and allows rapid production of the spare part on Earth. And we also see value in mental health frameworks, scheduling reactions, stress monitoring, and strong teamwork apply in submarines, polar station, or offshore platforms. And finally, small life support sensors for air and water quality can be used in schools, hospitals, or homes. And energy efficient power management and modular habitats can also inspire sustainable architecture. And we can continue with Arshleen.
So, hello everyone, I'm Arshleen, and I'll speak forward for the last points that we have. So, the first that I'm speaking about is the guidelines to be applied to daily life on Earth. So, this topic usually it surrounds at what principles are we proposing through our proposal, which can be followed here on Earth. So, first off, like we are going certainly under a climate crisis, and through our proposal, we are trying to come up with a spaceport or a launch pad on Mars, which can be dust resilient. It can be like solar energy generated and AI managed. So these principles can even be used here on Earth to reduce and mitigate the challenges of climate stress and resource scarcity at places where there are less resources, such as extreme environments. For example, deserts or like maybe in Antarctica. So, through our project, we are trying to offer a blueprint that can be a support system of sustainable living here on Earth. And the next point, Hannah, can we please move forward?
Sorry, I have problem with computer.
Oh, please take your time. It's okay. Now, coming to how it would be managed and how it is possible, and the chances that we are taking it to make it sustainable. So, the first is the Sustainable Development Goal 9, that is innovation and infrastructure. So we are trying to come up with a new proposal wherein there is in situ construction and sustainable materials that we think can be replicated here on Earth for sustainable development. The next is Goal 11. So we are trying to propose sustainable community, sustainable living, and green living. The next is Sustainable Development Goal 12, that is responsible consumption. So, but obviously, when you're in the outer space, you won't have many resources and you won't have an option to go and get things for yourself. So, it needs every sip or every bite needs to be pretty responsible and thoughtful. So, we are trying to tackle that goal too. The next is climate action. As stated in the previous slides, we are coming up with a proposal wherein we are trying to take in situ resources, that is regolith, and even solar panels for energy generation and sustainability. So we are trying to even tackle the climate action. So some of the goals that we are trying to achieve for the Mars Launchpad can be replicated here on Earth and can help towards can help us to go towards the sustainable development goals. Next. Coming to research. So how we are trying to do our research and through our proposal. So our proposal is actually kind of functioning as a living laboratory, wherein there's research and human adaptation to low gravity, radiation protection, and even AI managed launch operations. So it explores the ISRU construction, which is using the regolith. So our spaceport is mainly comprised of regolith construction with biopolymer plastic use. So just the space Launchpad is biopolymer plastic, but the rest of it we have tried to explore into regular construction with parts under the surface of Mars so that it tries and protects with the solar radiations. As we know that Mars has pretty thin layer of atmosphere. Next, coming to the management system and how we would manage things. So imagine if we're here on Earth and then we are having a facility on Mars, and how can we actually collaborate or talk or converse with the people back there? So we are trying to do AI-driven management hub monitors, which would support life systems and energy, traffic, and even emergency systems in real time. So this would be tracked through holographic dashboards that'll ensure redundancy, transparency, and even rapid response. And I think even in the upcoming years, we would be able to do all of this here on Earth super soon with the tech that we have. Next. Coming to quality of life. So as it was stated by the previous members that if we are there in isolation, it'll be super tough to tackle with mental stress, physical stress. So we are trying to have mindfulness sessions, storytelling, meditation, but even when we are on like the outer space and not on Earth, our body reacts to it. So basically, we have a tendency to develop kidney stones or even our bone density pretty reduces. We can break off a bone pretty early. So we are trying to integrate recreational activities with gyms, routine sessions, and even the use of vertical gardens or greenhouses that will support life there and it will make you feel that you're at home and at peace. Next. Coming to how our spaceport is and what we have imagined for Mars. So the center one, all of us can see it's Launchpad. So it's basically like made of plastic biopolymer. That's the black part. Then you can see two hemispherical domes. Those are greenhouses that will support like green plants through aeroponics, hydroponics. And the one that is like a rectangular box you can see just right out front, it's at the med bay. So Launchpad is a place where there can be some emergency situations and we would need extensive emergency care. So full on med bay there. Then the one with the solar panels on top is the RAM. It is the robotic part wherein there would be actually machines and AI-driven monitor screening systems that will monitor everything what's happening with the launch systems. And the next that you can see that's going beneath the surface of Mars, that is the transit wherein people would come and go from. So it's basically acting as a spaceport, like here on Earth we have an aeroport or like airport. There we would have a spaceport, and that particular part is underground just to save you from harsh radiations. And all of the system, as you can closely see, that it's lower than the ground. It's basically situated in the crater. That's for one particular reason that if launch like it would cause less dust storms and would reduce like noise, dust, and everything. So for that reason, we have chosen a particular crater, and half of the construction is underground. Next. So these were some of the references. We have keenly looked into a lot of material to actually start with our research first rather than straight away jumping into the proposals. So these are what articles we have gone through and the websites we have gone through to actually come up with a proposal. Thank you so much, everyone, for listening to us and joining us here. So, this was by Pawana, Hannah, me, Arshleen, and Ismel. And these are our details right here. So, you can reach out to us anytime. We'll be happy to talk to you guys. Thank you.